Heat. Now, any notes you prepare now, that's the note that will help you in your year one. Because JAMB syllabus, when divided into 4, if you divide JAMB syllabus into 4, two parts of the JAMB syllabus is 101, 102 physics in your year one. So whatever you cover now will help you. Therefore, don't just use Jota. You use Jota today, next day, next page, other page, like that. No notes. Have a simplified note, a complete note for any of these subjects that will help you. If you have only one note, you can share the note so that you cover any topic, cover that topic so that you can read it on your own. That's the only thing that will help you. Now, let's start with the definition of what is called heat. Heat. Have you ever heard of heat before? So what is heat? What is heat? Yeah, somebody give me a definition here. What is heat? Is the what? Is the measure of a measure of. Thank you. Yes, any other person? Heat. What is heat? Everybody here did heat from SS1 to SS2. Everybody here did heat. So there's no way you cannot talk about something like that. I'll direct my questions sometimes to you because I know you know all this, except if you stop reading already. Heat. Heat. What is heat? Anybody from here? Heat. Yeah, I was surprised. Oh. Nah. Yes, what is heat? No. You are defining another area of heat. It's not measure of the degree. You are defining another area. Yes, any other person? Please, feel free, express yourself. That's learning. Any other? Any other? Sorry. Yes? Heat. It's form of thermal energy. Thermal, use that right word. You're a physics student. Don't just say energy. Energy buribu. Energy ebuka. Yes? Okay, thank you. So, call heat a thermal energy. Can you say it? Again. Again. So, it's the total thermal energy in a system. When we talk about thermal, we're talking about the degree. That is the use of temperatures. Anywhere temperature is applied, we're talking about heat. We're talking about heat. Now, what is the unit of heat? What is the unit of heat? Joules, thank you. Heat is measured in joule. That's correct. What is the name of the instrument used in measuring that heat? Calorimeter. Thank you. Onko na sim thermometer eba. Oyan kwesikometer aka na onu ya. Clean ye of ma. The degree of that measure of the heat is used, or you measure heat using a what? A calorimeter. Using a calorimeter. Calorimeter. That is the instrument for measuring heat. Now, this heat we are talking about We're going to group the heat into many. Let's name them. Let's just take them one by one, beginning from the first part of it. The first part of this heat. First, let me ask the question. If heat is measured in joule, give me the dimension of heat. Everybody. Because that's one of the things you may see in your JAMB exam. And if you worry that you are in trouble, if you don't know. What is the dimension of heat? Heat. Yes? I'm listening. Just raise your hand and answer. Try and contribute. It will help you. Yes? Any M. Dimension. Dimension. Yes? Yes? Kilogram meter. By the word dimension, you must be specific. What you gave me now is a range of derived units of it. Yes, dimension of heat. ML. You are in order, yes? ML. ML what? Okay. Now let me see. So when we talk about heat, please, I want you to follow up. Don't just wait for note. You have nothing to do with notes. What you needed is informations. Jot them down, follow them up, understand these things. Now, when we talk about heat, we say that heat is measured in joule. And joule is the same thing as Newton meter. That is joule. So, is it correct? Is it correct? Do you know that joule is also the unit of work? And work is force times what? Perpendicular distance, not just distance. So this is force is here. Distance is this. So this one in physics is kilogram meter per second square. And you multiply it by this. Kilogram here. Meter and meter is meter square. Seconds raised to power minus 2. So dimension now. Kilogram is mass. Capital letter mass, M. L, length squared. T raised to power minus 2. So this is the dimension of heat. That's the dimension of heat. So everything, every parameter in physics goes with the unit. And as long as unit is there, you talk about dimension. Very, very important. Please, when you want to read, don't just read as if you are in a hurry. Go through a topic, get basic informations out of it. Thank you. Now, the heat is grouped into different headlines. We take up the first one. First one is what is called expansivities. What is called what? Thank you. Expansion. You cannot talk about heat without expansion. It's not possible. It's not possible. Do you know why you cannot stand under the sun for a long time? You know why? Who can tell me the reason? The reason why, as the sun is like this, you feel like, let me go under shade. A place that will cover you. Do you know the reason why you can't stand under the sun for a long time? As long as you are not busy, you are just standing under the sun. So why do you look for where to put your head? Because of the heat radiation. So what type of issue of the heat radiation now? What type of the issue of the heat radiation? Anytime you are standing under the sun, intense sun like this, do you breathe well? Do you breathe very well? Yeah, then you must be a millipede if you breathe well. If you can breathe very, very well under that, then you are classified under such group. Because that intense remove lot of oxygen that you needed. So you can't be comfortable at all. So heat has much effects. Those of you, if you have dog in your house, you discover that under the sun like this, when it's under the sun, how do you know that the tongue, thank you, the tongue will be out? And not now your physics. Why the tongue of the dogs always hang out whenever any time is at the frame of the intensity of the sun or any other heat. And the reason is that the sun has very high temperature, body temperature. So under the sun is a problem. It can't breathe well without the tongue out, so that much oxygen is inhaled, because the nose will not be enough just to breathe in. That's even you, if you run small, you normally open your mouth, both mouth and this thing, and start. Because heat has effects. I want you to know that. So this heat now, one of the effects of heat is called expansion. It's called what? Expansion. That is where we got the word expansivities. And I'm going to begin with the area that used to give us problem in that expansivities. I have one. Expansion is defined as what? Expansion is defined as what? Expansion is defined as what? Thank you. Somebody said increase in length only. Increase in dimension of a body. Increase in dimensions of a body. That is called expansion. It can be length. It can be area. It can be volume. It can be nature. That's expansion. And now this expansion, we have different ways of this increase. One is called linear expansivity. Can you mention that? Another one is called area expansivity. And the next one is called what? Cubic expansivity or volume, yes. Cubic expansivity. Now, these three, that's the first thing you're supposed to know before you now move over to applications. Looking at these three, I know all of us studied the three, but I'm going to touch these three again. I will join the three of them together, summarize them, and then present different questions in different areas. Because that's exactly most of the problems we have in JAM. Those applications, you can even with your sense answer them. Like, for example, advantages, disadvantages, applications, and all that. But all those mathematical aspects are normally, they are the ones needed mostly. So let us look at the three of them. Let's define them one by one. Let's define, each one we define, we bring in the mathematical application. So let's take up number one. Right. Linear expansivity. Linear expansivity. That's number one, linear expansivity. We use this time to summarize all. Now, right. Linear expansivity is the increase in length. Linear expansivity is the increase in length per unit length. Increase in length per unit length. Per unit length. Per degree rise in temperature. 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 Full stop. The unit is per Kelvin or per degree C. The unit is per Kelvin or per degree C. Per Kelvin or per degree C. This is the unit. K raised to power minus 1 or C raised to power minus 1. That's the degree of this. Per degree C. So this is the unit. Okay. Now let's continue. I want you to read up what you have. Read it for me. 1, 2, go. Thank you. Now that's definition. Let me bring in this definition. It will take us to other areas. We say linear expansivity normally is known by alpha. By what? Alpha. Linear means alpha. That this alpha is the same thing. That the alpha is the same as increase in length all over per unit length. Thus you have original length, if you like. Original length, can put it this way, times temperature rise. Now this is what we have. And for us to use this mathematically, we say that increase means L2 minus L1. Original length is L1 into temperature change is delta theta. This is temperature change. We can change this method by saying that the same alpha is L2 minus L1 over L1 into theta 2 minus theta 1, which can also move on now by saying that that L2 minus L1, if we cross multiply, is equal to alpha L1 into theta 2 minus theta 1. So this is the same. We can further move this down by saying that the value of the final, because L2 means final length, is the same as L1 plus alpha L1 change in temperature. This is the same as L1 into big bracket 1 plus big bracket 1 plus alpha small bracket theta 2 minus theta 1, all closed. So these are possible equations that we can derive from that of the linear. And each of them can give you a solution to a problem in any exam. Just understand exactly the reasons why they are here. This form of triangle is change. Now, so that's exactly for the linear. And we know This alpha, I call the alpha linear expansivity. And the LU2 is final length. LU1 is original length. Theta 2 is final temperature. Theta 1 is original temperature. That is exactly what you have here. That is linear. So hence you have this. It means you can answer any question from the linear. Please understand the formations, and that will help you. So let's move over to the next one. We have to form all these things. Then we go into jam past questions. Anywhere you stop, you will not. You will just continue on your own, because you can see anything at any time. Alpha means what? Linear expansivity. Lu2 means what? Final length. Lu1 means what? Thank you. Triangle means what? Change in temperature. This is change in temperature. I can say change in length. I can use the same triangle here. The triangle L, yeah, change in length. The same. Now, I want you to look at this particular equation. If I number this now, 1, 2, 3, 4, 5, 6. Look at the 6 of them. The one you use mostly in JAMB is equation 4. Because this equation 4 has much interpretations. 1. The 2, they are the same thing, but we just form equations. Look at this. Lu2 minus Lu1 is the same thing as alpha Lu1, change in temperature. And what each of them is known as increase in length. Please pronounce it. Increase in length. Again. For each of these. Now, each of them is also known as variation in length. Say it. Again. And each of them is also called safety gap. Safety gap. That's why when you come to JAM, they use different terms. So understand those terms. Lu2 minus Lu1 is the same thing as alpha Lu1 change in temperature. And if you pick this one, it's the same. If you pick this, so you can make use of the one that will solve your own problem in exam. If they say calculate the safety gap, and in that area you have the linear expansivity, and you know that this side there's no linear here. Okay? If you are giving linear expansivity, original length, and temperatures, you just make use of this, the same thing. But in a question, if you are giving final length and the original length, you make use of this. That is it, the whole thing. So this equation 4 is very, very important. There is the same thing, it's formed from the same area. But almost all the time, both JAMB and screening, you discover that this equation 4 will give you the answer, immediate answer to the question. There are 3 names I gave to it. One is what? Increase in length. Another one is what? Variation in length. Another one is what? Safety gap. Safety gap. That's all. Thank you. So we are through with this. When we go into solutions, are you raising your hand? Okay. I can't really hear you. Huh? Mm-hmm. Original length. Theta 2. Anything 2 is final. Theta 2 is final temperature. Theta 1 is initial temperature. Mm-hmm. Mm-hmm. So you can use the word final and initial, or final and original. Anyone. Anyone. Okay. Then let's come back to the next one. We now talk about, next is area. Area, expansivities. Now today, this marker, they are really crying, All of them are crying. Even the third one, this one, it was okay before I used it. So add more. Thank you. Yeah. Well. Oh, Jugo. I'm pretty clean. So let's now go over to the area. Oh yeah, let us write the definition again. You know why I'm taking these things one by one? I know that some never offered physics to a level. That's why you get to the grassroots of the whole thing. So let's take the definition again. Area expansivities. Now write. Area expansivity is the increase in cross-sectional area. Is the increase in cross-sectional area. Is the increase in cross-sectional area. Increase in cross-sectional area. Area expansivity is the increase in cross-sectional area. Increase in what? Cross-sectional area. Per unit area. Per unit area. Per unit area. Per unit area. Per degree rise in temperature. 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 Full stop. The unit is per Kelvin. The unit is per Kelvin. The unit is per Kelvin. That means it has the same unit with linear. That's the meaning. Per Kelvin. Full stop. Please, read out, read out. One to go. Thank you. Now look at that definition now. Look at it here. Please, I want you to look up. Hence, you talk about area. Area is represented by a letter known as beta. That's the area. This one is represented by a letter called what? Alpha. But this is beta. So for this beta now, we said it is 2 times alpha that will give us beta. So hence you mention area. It is twice alpha that will give you 2 times alpha that will give you area. So if it is so, it means when this beta is equivalent to A2 minus A1 over A1 into change in temperature, then it means that this one coming here will be 2 times alpha equals A2 minus A1 over A1 into theta 2 minus theta 1. And that is exactly what will give us that A2 minus A1 is the same as 2 alpha A1 change in temperature. So this is the same. So if this is the same, it means we have also arrived at the point of equation 4. Look at equation 4 here. It's the same way with this one, meaning that for this equation 4, all problems can be solved with this. All, easily. The same equation 4, very important. But I can still extend it by saying that A2 equals A1 plus 2 alpha A1 into change in temperature. I can still extend it finally to A1 bracket open 1 plus 2 alpha into theta 2 minus theta 1 bracket closed. These are equations. But I want you to know that equation 1, 2, 3, 4, this equation number 4, number 1 and number 4 are mainly natural equations. These equations, they are important. All over, they are the ones that form the other ones. So, but you must know them. So this is area. This is area. Area. Now, for this area, what am I going to call equation 4? Each of the linear equations there. Please look up here. Look up, look up. Look at equation 4 here. A2 minus A1 has 3 names. Has what? Has what? And the same name is given to 2 alpha A1 change in temperature. Now, what is the name? First name is called increase in what? Thank you. Second one is called what? Variation in area. Third one is called what? Safety gap. Safety gap. Thank you. Which is correct. Which is right. So anywhere you see a question, no matter the term used, that is exactly where you're coming. So you get to that point and get information there. You know, we started heat from 01 so that many can I know that many of you already know all this, but there's no way we just walk on space, because there are some that are yet to know what is heat. Okay, now we'll move over again to the next one. So next one is called cubic. Cubic expansivity. That's the next one. Next is a cubic expansivity. If you can take your time, go through these things, then you know that the questions, those jump questions and screening questions are not very hard. They are not hard. Hence, you know these things. So after the whole thing, take your time, study it. Okay, can we move over to the cubic expansivity? Are we through with the area? Please be a fast writer. I can move on now. Okay, so let's define cubic expansivity. Cubic expansivity. All that we are talking about is about solid. Solid, solid, solid only. Linear, solid. Area, solid. Cubic, solid. It's after that we now talk about liquid. So these are all solid. which means if it is possible that this microphone can expand at the intense of heat, because this is solid. Okay, so let's define this. Cubic expansivity is defined. Cubic expansivity is defined as the increase in volume. As the increase in volume. As the increase in volume per unit volume. Per unit volume. Per unit volume. Per degree rise in temperature. 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 Full stop. The unit is the same. And what's the same? Per Kelvin. Thank you. That's the unit. Now read what you have in your note. 1 to go. Thank you. We are talking about volume now. And look at exactly the measure of it. As you look at the board now, we are talking about cubic. So when we say cubic, it is given as a capital letter Y. Cubic is Y. Cubic is Y. And what's another name for it? Gamma. Thank you. We have alpha, beta, and what? And gamma. So we say that this is equivalent to 3 times alpha. 3 multiplied by alpha will give you gamma. Will give you gamma. And we also say that this same is the same. Please, I want you to look up here. Stop writing. There's an equation I want you to know how it is formed. We know that beta is equivalent to 2 alpha. Where? Now, from here now, what do we have in this equation? Please, everybody, look at the board. This equation now, is there any of this part of this equation that is here? What is it? Alpha. Make that alpha the subject. If you make alpha the subject, what are you going to obtain? Beta over what? So if I come back to this place now and replace alpha, I have 3 here. Into this alpha is now beta over 2. Then I can now obtain that 3 beta over 2 will give us the same equation. The same equation. So I want you to know where I formed this. Hence, you know this equation. You go direct because JAMB does not require most over derivations. What you needed is the short methods. So learn all these things. So the same volume, this same volume expansivity is related to the area by this equation. Now, let me come back to the first derived. This gamma now is the same thing as volume, final volume minus initial volume, all over initial volume into theta 2 minus theta 1. And this one already has been given as this. So I can say 3 alpha here equals V2 minus V1 over V1 into theta 2 minus theta 1, which is the same as V2 minus V1, equivalent to 3 alpha V1 into change in temperature. The same equation, the same formation from beginning. From linear, the same way. From linear, the same way. from linear the same way. Just look at it the same way, the same form, the same formation. So take it that same way. So this one, that's one, the same equation. The same equation. We just simply make this equation 1, make this equation 2, make this equation 3, and which formed here, this particular one, 4, and then 5. So what we needed is the equations. So that no matter the question, based on the calculation of linear area and volume, you solve it. I want you to go through this because I'm going to present some questions here, and I would like you to go through the JAMB past questions. Get questions from there. That is exactly what will help you. What will help you. So after my questions, take your time. Check if there is any question anywhere that is difficult. Present that question. Present that question in our next class. Because our next class, I will use 20 minutes to answer your questions for the previous. And then I'll go into the next one. If you want to learn, if you want to be strong, learn to solve these things on your own at home so that you will be able to present issues. Very, very, very important. Okay. Now, based on the 3 areas, these 3 equations of linear, area, and cubic, let me present my questions. I'll present about 5 or 6 of them and stop and leave this and allow you to do the rest. I can introduce the other part of the topic. So now take my question number 1 if you are free. I want everyone to participate. Solve. Solve. Select equation, solve. That's the only way. That's the only way. And then marry a miracle. Or practice that will make you perfect. So question number 1. A metal rod, metal, M-E-T-A-L, metal rod, R-O-D. A metal rod of length. A metal rod of length. A metal rod of length, 400 millimeters. 400 millimeters at 400 millimeters at 10 degrees C. At 10 degrees C. At 10 degrees C. Is heated to 110 degrees C. Heated to 110 degrees C. Heated to 110 what? Degrees C. Full stop. Calculate the variation in length. The variation in length and the final length. Variation in length and final length. Full stop. In bracket, alpha Alpha equals 5 times 10 to power minus 5 per Kelvin. Close the bracket and solve. See it on the board. 5 times means exponential. 5 exponential minus 5 per Kelvin. EXP exponential per Kelvin. Per Kelvin. Full stop. Hence, you get any of the two answers, tell us. Practice. Remember, they call it perfect. Don't just fold your hands. Walk along with others. Want to see if we can use the time to cover the two areas, the whole that topic. No. Somebody asked this question, are we changing the millimeter? No. You are not changing temperatures under this because the unit is per, not degree, per. So you don't change any temperature for any of the expansivities. You go by the one given to you. And you don't change the length as well, yes? You don't change length, you don't change temperatures. That's a good question. Ask him why. Instruction can you ask one why? African man. Nji question as a question. In your physics or instruction kobo. Instruction. In where pay. Per degree. And the per Kelvin is the same. You don't convert anytime you have pay. You can convert when you have degree. Directly, degree. Not pay. Pay is a limit unit. Yes? Huh? Change the length is 2. That's 2 millimeters. Somebody got change in length as 2. As 402. As 402. That's what I want to hear. Bro, why? Bro, why? Come Charino. I want to hear, want to listen to the answer. Let me listen to others now. Fast. A minute is okay for you to do something. Your jump is only 40 seconds, yes? .402 millimeter and yes. Just shout it. Yes, anybody? Final length 402. Variation is 2. It's 2. That's what I'm looking for. Please let everybody participate. You don't just learn by folding your hands. Okay. No time again. Okay. So let us now look at the question. Please give me the first parameter in that question. Alpha, is that alpha the first? No. L1 is what? Forward. 400. Is that 400? 400 millimeters. Yes. What's the second? Theta 1. Theta 1 is what? 10 degrees C. What's the next? Theta 2. Theta 2 is what? 110 degrees C. What's the next? Alpha. Thank you. 5 exponential what? Minus 5 per Kelvin. These are the parameters. And the first question is what? Variation in length. So for the question I, variation. For the variation, we say variation equals, let's look at this. We have L1 and change in temperature. Therefore, alpha L1 into theta 2 minus theta 1 will just solve the problem for me. Because these things are here already. So I will just replace. Alpha is 5 exponential minus 5. Length is 400 times this. This minus this is what? 100. So with this now, I can easily obtain the variation. And how? I can change this by saying, just look up here. I want to encourage you that this is jumbo. This is jumbo. Learn to solve problems without the calculator and also to solve with calculator. Because you are not carrying your calculator to the hall. That's the truth. You are not carrying any calculator to the hall. You make use of the calculator in the system, which is not scientific. It is just plus and minus and division. Even some of the systems, the calculators in them sometimes may not be okay. It's better you understand this. So let's look at the board. Let's solve without pressing it. 100 multiplied by this will give us what? 40,000 times 5 is what? 4 times 5 is what? Simple. Just write 20. How many zeros are here? 4. 1, 2, 3, 4. Times 10 to power minus 5. Solving the problem, I'll cancel the number of zeros to equate this. 1, 2, 3, 4, 5. We remove this. So what is remaining? 2 millimeters. So that is my answer for variation. What you needed is just to know the number of zeros. That's the number of decimal points that we merge this. That's okay. You go with it. So this is 2 millimeters. Then the next question now in II. The next question said what? Final what? Final what? So anytime in your jump you see final length, it is better for you to calculate variation. Because jump has time and it is 40 seconds only for each question. Not up to 1 minute. So learn how to solve problems there. Don't just use the time for 5 questions for only 1 question there. Ebi ne make it derive chi wali le no eba no. It derive gidi ka agwoge. At the end of the whole thing, if you hit about na neck. Learn to solve these problems the very simple way. Anywhere we enter, find out exactly how it is solved easily. So here, already, whether they asked you to do this or not, this is just simple for you to calculate, up here. Calculate it. When you calculate it, repeat the equation that L2 equals L1 plus alpha L1 change in temperature. Look at it now. With this, I am looking for L2. And I have L1. What's the value of L1? 400 is here. Plus, the whole of this is equal to what? Is equal to 2. So this plus this will be what? 402 millimeters. That's all. That's a simple way of solving such problems. That is question 1. Number 2. I'm going to pick a question now. Does it work? Okay, there are some there, but I needed one particular question in JAM. I'm going to pick a question now from JAM. Yes. We just answered one linear. I'll give you 1 cubic. We'll just select 1, 1, 1, 1, and then the same 1, 1, 1, 1. Because we are combining all at the same time. Now, right. Are we ready now? Now, right. A black, okay, you are still writing. Let me give you a little time. Please, if you are true, let me move on. Are we true now? Okay. Now, right. A blacksmith, a blacksmith heated a metal. A blacksmith heated a metal whose cubic expansivity is, look at it on the board. Cubic expansivity is 6.3 times 10 to power minus 6 per Kelvin, comma. Whose cubic expansivity is this, comma. Determine the area expansivity. Determine the area expansivity of the metal. Determine the area expansivity of the metal. Determine the area expansivity of the metal. That's a good relative question. Determine the area expansivity of the metal. Full stop. I'll still pick another from here. So the owner, thank you, and allow me make use of this. Now solve. That's the question. I gave you the first one from the linear, second one now from the cubic. I'll still pick another one on the side of the area. Okay. 4.2. Minus 6. Okay. Oh, some road solutions, so I'm waiting. Why? Just look at the, hence we mention cubic. Go to the list of cubic. Find out exactly the one that you use. If we mention area, go to the group of area. Find out the one you use. That is learning. 4 point. Okay. -6 per Kelvin. You are not supposed to be here, so that you see clear. You are not supposed to be here. You're supposed even to sit at that front. Supposed to sit at that front. Glasses are meant to be closer because of the radiative distance. You can strain, I get strain. If we are, because you're putting on glasses. So you can say on so. I don't know so, nanka only on so, na front arm. Thank you. Thank you. Yes. 4.2 exponential -6. Our time is going, so let's just work on this. Thank you. The only thing given to us in this question is what? Is the cubic what? And we are asked to calculate what? Area. So what we needed is relationship. We just say cubic is equivalent to 3 area over what? Over 2. That's all. Then we solve the problem. And what's the problem here? This is equal to 6.3. This one times 10 to the power -6 multiplied by 2. Multiplied by 2 equals 3b. Now, 2 times 6.3 is what? 12 point what? 0.6 times 10 to the power -6 equals 3b. Then the value of the b will be 12.4. Sorry, 12.6 exponential -6 divided by what? 3 into 12 is what? 3 into 6 times 10. This one will not change. Times 10 to the power -6 per Kelvin. So that's the right answer. Thank you very much. That's the answer. Hence, you see a question. Find out exactly the direct information. Now, I'll pick another one from the area. At least it has to go round. Are we through now? Okay, write this question, that of the area. Now write. A metal plate has a surface area. A metal plate has a surface area. I repeat, a metal plate has a surface area of 3 meters squared. 3m raised to power 2. Yeah, 3 meters squared. At 30 degrees C. 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 We'll stop. Determine the increase in area. Determine the increase in area. Determine the increase in area when it is heated. When it is heated to 80 degrees C. When it is heated to 80 degrees C. When it is heated to 80 degrees C. To 80 degrees C. Full stop. In brackets, alpha, yeah, linear expansivity. Alpha equals 4.0 times 10 to the power minus 5. Alpha, yeah, in bracket, linear expansivity, which already you know as alpha. Okay? Alpha is 4.0 times 10 to the power minus 5 per Kelvin. You close the brackets. We selected 111. If we can be fast, we go back again, select different ones, 111 also, and close at the end of it. Then you will now go back, study more, and maybe raise the ones that has problem. Yes? 8.0. Good. Yes, next person. 0.0. Put it in standard form. All the answers are in standard form. Minus 2. Any other? Ijikwe calculator yet, whatever answer. In happy calculating, in happy yet, no answer yet. No answer yet to. Yes, yes, yes. Side there network at the chapel. That's such a question side of more of my do I want a partial network. I'm still waiting for the results. Baba no show. It's a solution nature the thing. No show. Take your time and review the topic, please. Yes? 3.012. Can you ask the catcher? Can you ask the catcher? What are you looking for? Increase in increase oh catcher. 0.012. Yes. 1 point. Okay. Thank you. 0.0 and 2 minus 2. Okay. So look at the question now. Just give me the parameters. Let me have the parameters in that question. The first one is what? Huh? Original length. Initial length is what? 3 meter. Hey, sorry, area. Oh. 3 meter what? Please remind me what we were asked to calculate. Increase in area. So the first one given to you is 3 meters square. Where? Next one. Initial temperature. Please stop writing. Theta 1 is what? Theta 2 is what? Alpha is what? 4.0 times 10 to power what? Minus 5 per Kelvin. And we're looking for what? Increase in I will just say increase. Increase equals area. By area means 2 alpha A1. Change in temperature. That's the increase. That's what I gave you as increase. I give it to you as increase, as variation, as safety gap. So this is what you're supposed to use directly. 2 is here. 2 times alpha is 4 times 10 to power minus what? 5. Area, initial area is what? 3 into theta 2 is what? Minus 30. So this is 2. I can still say 2 times 4 times 10 to power minus 5 times 3 times this minus this. 50. Let us just do it the same way. 2 times 50 is what? 100 times 3. 300 times 4. 1,000 what? So I have 1,200. Multiply by 10 raised to power minus 5. Then look at the board. I told you, check the number of zeros to remove it. So I have the number of zeros, 1, 2, they are off. So that 2 will be removed here. Remaining what? Remaining minus 3. This minus 3, how many zeros? 3 zeros up here. So I will come back to 12 and act 1, 2. Oforole? 1. That means I have 0.0012 what? Meter. So this is the variation. Okay. Meter squared. This is the variation in area. This is the variation in area. And if I put it in standard form, it will be 1.2 times 10 to power what? Minus 2 meters square. So any of the above. Any of the above. That is how it's supposed to be. So hence you see a question. Go direct to the solution that will, the one that will solve that, or the solution to the question. Now, we may not go around this time because of our time, but we'll go back again to the same sequence. Are we ready now? Fast. Another chain of questions now will come up. Different ones from the ones we solved before will come up. Just to tell you that in every topic there are ideas. Every topic has ideas. Not just one, but different ideas. I hope you are ready now. Okay, let me read out. I read the second question. You can turn it upside down. So let me now write two metals P and Q. Two metals P and Q. Two metals P and Q are heated through the same temperature difference. Are heated through the same temperature difference. Are heated through the same temperature difference. Through the same what? Temperature difference. Full stop. If the ratio of the linear expansivities, if the ratio of the linear expansivities of P and Q, linear expansivities of P and Q is 2:3. Look at it on the board. 2:3. 2:3. 2:3. 2:3. And the ratio of their lengths, the ratio of their lengths is 3:4. 3:4. 3:4. 3:4. Full stop. Sorry, 3:4 respectively. 3:4 respectively. 3:4 respectively. Full stop. Determine the ratio of the increase in length. Determine the ratio of the increase in length. Determine the ratio of the increase in length of P. Increase in length of P to Q. Increase in length of P to Q. Full stop. Increase in length of P to Q. Boom. That's the question. So we're in another stage of it. Gradually, that's jam for you. Different ideas. Someone gave me this one. I have two other questions easily to pick from here. Now get me the results. Get me the result immediately. This topic, is it linear, area, or cubic? Which one? Linear. That's correct. So that you know exactly where you're going to. You know exactly where you're going to. Just go straight. Yes, 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 yes. Many people wrote solution. Nature. Nature. No. It's linear. Okay, you know. Yes. 2:1. Yes. 1:2. 1:2. 1:2. Yes, yes. Any other? Look, there is no magic. Oh, just the process. You keep working. You will discover that. Look, you get, yes. 1:2. 1:2. 1:2. Any network? Hey. No show. Okay. 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 Thank you. That's exactly why it's a national exam. They can set anything, any of the ideas directly. That's a very simple thing I want you to do. Now look up here. Look up, look up, look up, look up. How many metals are involved? 2 metals, thank you. 2 metals. What and what? P and what? P and Q. And the final answer is based on what? On ratio. Based on what? So what you're supposed to do in exam, hence you see ratio. Be ready for that division. What you're supposed to do, you just come back to the 2 of them and write down that L2 minus L1 over L1. Change in temperature. This is for P. I want you to understand this. Look at the board. Divided by L2 minus L1 over L1, change in temperature. This is for what? This is for Q. And then you go by that. For the first one, read that question and give me those parameters. What are the first parameters given to us? Linear what? Linear expansivity. Okay, each of them has linear expansivity, am I right? Okay, because of the linear expansivity, let's go by the direct solution. If the linear expansivity is given to you, please read the question. Are heated to the same what? Their temperature difference are the same, okay? Thank you. Yes? If the ratio of the what? Thank you. So what exactly are we looking for? Ratio of what are we looking for? Increase in length. So if I record this now, let me go this way. If I write down alpha equals L2 minus L1 over L1, change in temperature. What are we looking for here? Increase in, which one is the increase in length? Again. Again. So if I make L2 minus L1 the subject, L2 minus L1, I will obtain what? Alpha L1 changing what? Hence, I am looking for this. I will no longer bother. I will just carry this one direct for each of them. So I can leave this one because I am looking for this, their ratio. So for the first one, L2 minus L1 of what? Of P divided by what? L2 minus L1 of what? Of Q is the same as, look at the board now. What is alpha? What is alpha of P? Look at that question. Alpha of P is what? So the position of the alpha for P, I'll write 2 times. What is the alpha of Q? I will come down and write 3 for Q. 2 for P. Alpha P. Alpha Q times. What is the L1? L1 of P? 3 times. What is the L1 of Q? 4 times. Change in temperature. Are they the same? Yes. I'll just say change in temperature, change in temperature. These two are the same already. Is there any other thing that's the same? 3 is here, 3 is here. Any other thing? 2 here to 1, 2 here to what? So what's remaining up? What's remaining down? That's the answer. Just find out what you're looking for. Make it the subject. That's all. When you make it the subject, it will be easy for you to group it. You go direct. Don't look at it so complex. No. Okay. Are we through? In our next class, I'm going to test you 1, 1, 1. At the end of it, we now continue with the topic, round up the topic, both advantages, disadvantages, and all that, and applications. Because every topic has very sensitive areas. When you cover those sensitive areas, you just revise the remainder. And that will help you. And that is exactly. So please, I want you, when you go back, study, go through the compiled questions, solve more of this, so that you have questions to present. And that is exactly what will help you learn more. Don't just go home and fold your hand and put your phone. No. In with time, this time to read, or was it up to 5?